Okay, so first I will introduce myself. Okay, so my name is Ashok and I have a total 7 years of experience into the DevOps, and I'm Azure admin certified and DevOps certified. So in this course, we are discussing the complete Azure DevOps, and also we'll discuss some of the basic concepts related to Docker and Kubernetes and Terraform also. Complete course syllabus is uploaded in the GitHub, and here we can see the complete syllabus. I will also share this link. You can also refer. This is a public repo. You can access directly. And this course is divided into 5 sections. Okay. And each section we will cover different topics related to Azure DevOps. And in the first section, mainly focusing on the Azure boards. In the next section, we are focusing on the GitHub and Git related operations. In the section 3, the main pipelines we are covering, like continuous integration and continuous delivery. So what is continuous integration? We will talk about a little bit. And section 4 will cover the Azure artifacts and Terraform. Section 5 will cover the Docker and Kubernetes related activities. And if you see, each section is having the tasks also. Once we cover the topics, the expectation is to complete the tasks also. This will benefit for your practice as well. So total we have 30 tasks according to the section wise. So if you get any doubts also in the task, ping so that we can also help you. Okay. So here the course files are also there, which will be useful for your practice purpose. Some ARM templates, web applications, Docker related contents, Kubernetes related contents are there, which will help you with the tasks. Okay, so let's start the session. So this PPT also divided into section wise. So we will cover each section. So before going into the DevOps, we will cover first a waterfall method. Okay. So previously, when we are developing the software in the olden days, most people are using the waterfall method. So I will give you a brief introduction about waterfall method, and we will go to the DevOps. So in the waterfall method, first is the requirement stage, where the system requirements will be gathered and those are documented for the software development. And in the next stage, they will design like what are all the hardware and software requirements required for the software. So in the next stage, they will develop the application which is required. They will do the coding and all. They will front end developer will do the front end coding and back end developer will do the back end database administration. They will do some SQL scripts. So those kind of all the development will happen in the development stage. So next stage is the testing stage where the entire system is tested for any faults and failures. Next is the deployment. So once the testing is completed, the application or the software will be deployed into the customer environment or it will be released to the market. The final stage is the maintenance, where we will fix the patches which are need to be released. So this is a waterfall method which will go one stage after another stage: requirements, design, development, testing, deployment, and maintenance. So which process is used in the olden days for the software development. Okay. So what happened with this approach is there are some problems with the waterfall methodology. Like there will be no software until the complete life cycle. Software means they will do the requirements development one by one, and they will release after the complete requirements are completed. So after the complete release only we will get the software. Next is a high risk. So in the initial stage they will gather the requirements for the software, but in the latter stage what will happen, in the middle of the project the requirements will change. So due to that they will again do the go to the starting phase, gathering the requirement, and then again doing the hardware and software assessment, and again they will go for the development. So due to this, again the process will continue like that, and the project timeline also will change multiple times if the requirements are changing. The next is the integration. So as we discussed in the development stage, the developers will do the development according to the requirements from backend and front end, and they will integrate the changes after all the requirements are completed. So which is like a very large portion of the code will be merged against front end and back end, which will result in a lot of issues for the integration. And next is measuring. So as the requirements are changing, it is difficult to measure how much time will be taken for each stage, and it is also problem in identifying the delivery dates for the clients or the releasing dates. So next is high cost. So overall the process is taking a lot of time, and it will also take a lot of manpower, so which will result in high costs for the application development when we use the waterfall methodology. So to avoid all these, we have the DevOps where it will resolve all these problems. And what is DevOps is? DevOps is a set of practices to code, build, test, deploy, operate, and monitor your application. And it is a cyclic process where each stage will be continuously going on, like build, test, development will be continuously going on in one circle, and deployment and monitoring operations are going in another circle. And each stage will have a feedback stage where if the build is not done properly, then it will go to the testing. Then the testing you will get a feedback like what are all the test cases are passing or failing. Based on that, again it will go to the development. Then the developers will code again and build the software again and test again. So once all are succeeded, then only it will go to the next stage like deployment. After deployment also, the application will be monitored continuously, and if any bugs or any system failures are there, it will be fixed. So this is a basic principles of DevOps, and DevOps will follow agile methodology, which will have planning, designing, develop, testing, deploying, and review. So this is the agile methodology which will be used by the DevOps. Each stage will be having multiple roles like planning, you will have the requirements. In the design phase, you will understand the software and hardware requirements. In the develop, you will do the application development. In the testing, you will check whether test cases are passing or failing for the application after building the application. And once the test cases are passed, you will do the deployment to any test environment. Once the test environment is deployed, in the review phase, we will monitor the application, and developers and manual testers also will check the application for any bugs. And it will go if to the develop stage if again any bugs are there. Like that, it is like a continuous process when we go with the agile methodology. And in the DevOps, the main thing is about continuous integration. So what is continuation integration is, so when developers writes the code, like front-end developers will write the code for the front-end application, and back-end developers will write the code for the back-end, like database related and some API related development. So once the coding is completed, they will give the code to the CI tool. So here CI tool will do the building the application from the source code, which is developed by the front-end and back-end developers. And it will run some automated tests on top of the application build. Once automated tests are completed, it will provide a feedback like whether the test cases are passed or failed. Let's say in case these are failed, so some problem is detected after running the automated tests. So in that case, it will again go to the developers, and the developers will do the changes again on the application code. If it is belongs to front end, the front end devs can develop their code and fix the issues. Again, the code will go to the CI tool, and the continuous process will run again, building the application, running automated tests. If any problems are there, then it will again go to the developers. So now the developers fixed the problem, then it will go to the continuous deployment part. So in the continuous deployment, we will take the build artifact, which is built by the CI tool. That build artifact is like a zip file or a war file for the Java based application. For the .NET based application, it will be the DLL file or exe file. Okay, based on the programming language, it will be depends. So that build artifact we will take to the CD, continuous delivery or deployment. And in here in the continuous deployment, we will have release pipelines. In this release pipeline, we will configure our environments like dev test, and we will deploy that build artifact to the environment. So based on your project, you may have different environments. The basic will be dev, UAT or user accept testing, and BT business testing. Once development and UAT business testing all are completed, then it will go for the pre-production. After then after approvals, it will go to the production. Okay. In each stage, in the dev stage, developer will do the sum of the checks. In the UAT, they will do some integration and front end related testing. In the BT environment will be provided to business people before releasing into the production, so that they can also see what are all the features in the new application they have. once the BT gives sign off or approval from the business team, it will go for the pre-production, and after approval it will go to the production. So it is like a process which will be defined inside the organization based on the environment. Some
Sure.
organization, yeah,
Yeah, you guys continue, okay?
yeah,
I'm dropping off.
yeah,
So
okay, thank
Sai, Hari, Anand, and Kiran. So anybody have any questions? Just feel free to ask Ashok. Right? Thank you, guys.
Okay.
Bye.
Okay, sure.
So here in the release pipeline, I have mentioned around 5 environments, but based on the organization budget and costing, they may have low environments also, like dev and pre-prod and production. Okay, that will be depends on the organization, but but we will have different environments for the different use case. One will be developers, and one will be the for the business team, and actual production also will go to the business team. And each stage will have the application code along with the infrastructure code. So here IAC means infrastructure as a code. So nowadays we are building the infrastructure also, which is responsible for the application using infrastructure as a code. So which is a ARM template, like Azure Resource Manager template, or mm, Terraform. Most used tool is a Terraform. In the Azure, we can also use a ARM template for the IAC. So this IAC stage will do the deployment for the resources. In the further sessions, we will discuss more on those topics. So moving on. So here the problems are solved by the DevOps. So it is bringing value to the customers with faster production cycles, because here the application is developed continuously, and the feedback also given by the test case, whether all the test cases are failing or passing. Based on that, the build will continue, and it will go for the further process, and all will be in a automated way. Once continuous integration is completed, automatically it will go to the continuous deployment process, which will be faster when compared to the waterfall methodology. And it will also increase the productivity for the developers, and which will result in higher customer satisfaction. So previously, one stage after another stage it is going, but here in the initial stage only some software will be there. On top of that software, they are developing the features one by one, and the productivity also increase when we develop smaller features in smaller chunks, which will result in the higher productivity in the DevOps. And it will also save the costs for the business, and they will go to the market and release the product within less time. And it will also enhance the quality of the software with test automation. As we have test cases in place, the software quality also increase, and they will also identify the bugs in the very early stage so that they can fix, and they will release the application. So which will enhance the quality of the software. And after a production deployment, you don't see much issues. And improving problem resolution. So as I said earlier, with the test automation, the problems will be identified in the early stage, If any problems are there, again in the after deployment, we will also do the continuous monitoring and continuous review of the application, which will identify the problems early before identified by the customers. So these are all the main points which are main problems solved by the DevOps. So when it comes to the DevOps tools, there are many tools like Jenkins, Azure DevOps, AWS DevOps, GitHub Action, TeamCity, Circle CI, and many more tools are there. So here some tools are cloud-based tools like Azure DevOps and AWS DevOps, GitHub Action. So Jenkins is like a self-hosted where we can install it on server and you can run it. And these are TeamCity, Circle CA also provided by the respective software providers. But most people are using these first four software: Jenkins, Azure DevOps, AWS DevOps, and GitHub Actions. So in this course, we will cover Azure DevOps, all the CI and CD part, and GitHub Actions also. So these both are the Microsoft products. So nowadays, GitHub Action also getting much popularity, but it is not matured yet. It is still some development is going on when it comes to GitHub Action. But Azure DevOps is completely matured DevOps tool where you will have all the options. Um, so there are many tools also. Let's go to some tools. There is one DevOps periodic table where you will find a lot of tools which are related to DevOps, and each one will be identified by some color codes. So here first you can see green color. It is saying Jira value management stream, and for the orange AI ops, and the gray color you can see continuous integration. These are all the continuous integration tools. Jenkins is there, Azure DevOps is there, then GitLab is there, Travis, Circle CA, Maven, Atlassian, GitHub Actions. Yeah, so many tools are available. You can refer this for just for the reference. And to become a successful DevOps engineer, you need to be proficient in these 7 layers, which we will call it as a DevOps burger. Okay. So each layer we need to have some proficiency. Then only you can become a good DevOps engineer. The first layer here is a programming language. Okay. So you need to have some basic idea about the programming language like Python or any programming language, JavaScript, Golang, or C Sharp. Anything is fine, but that is not a mandatory. If you have the basic programming language, that is enough. So next layer is a server administration. We need to have understanding about how Linux or Windows system will work. Okay. So next layer is a networking and security. So we need to have an understanding about networking, and this is mandatory. We need to have TCP, IP, HTTP, FTP, DNS, and SSL settings. So those things we need to have complete knowledge which related to network and security. So next is caching, Redis cache and memcache. So this is not required, but if you have the knowledge, then it is okay. And in the fourth layer, we have the database also, like NoSQL, SQL. So you need to have some kind of SQL knowledge also, SQL queries knowledge also. How the NoSQL will work and how the SQL will work. Yeah. So NoSQL means it will the data is not sequential manner. In the SQL, you will get the sequential data like Excel. NoSQL is not like Excel. So in the servers, you will see one more option like web server. We need to have understanding about Java, Nginx servers, timecode servers, IaaS, in Internet Information Services. So those kind of things we need to have the basic knowledge. So next layer is the infrastructure as a code. So where we will do the configuration management for the infra resources. So here the main tools will be Ansible, Docker, Kubernetes, and Terraform. So Ansible, we are using it for the configuration management inside our servers, and container, Docker container. So containerized applications, we need to use Docker, and container orchestration, we need to use Kubernetes. So nowadays Kubernetes, we are getting a lot of demand also. And next is the infrastructure provisioning. Here a lot of tools are there, but the major one is Terraform, and in the Azure Resource Manager templates. For AWS Cloud Formation. So these we need to have the understanding. Next is the main layer CI/CD. So here a lot of tools are there. So we need to be proficient in any one tool. Like so, first is the Azure DevOps, and next is the GitHub Actions. So these are the Microsoft tools. So remaining Jenkins, Argo CD, Circle CI, TeamCity. So these are all the third-party tools you can ignore. So focus on the Azure DevOps and GitHub Actions, the Microsoft products. If you are interested in AWS, then AWS code pipelines. And Jenkins also you need to have the basic understanding. So Jenkins is a open source tool which you can install and check, and it is a graphical user interface tool where you can configure all the CI/CD. So next layer is a monitoring. So in the monitoring, lot of tools are there. The main tools will be Prometheus and ELK Grafana. So nowadays we are using the microservice architecture. So most people are using Prometheus to monitor this microservice architecture. Microservice architecture means it will have the containerized applications. So in the containers, they may use Docker, and using the Docker, they will create containers, and they may deploy into Kubernetes. To monitor those applications, they will use Prometheus. So if you are in the Azure cloud, you can also use Azure Monitor, Azure Log Analytics. The next stage is the cloud. So there are different cloud providers, AWS, Azure, and GCP. So we need to be proficient in any one cloud so that all the clouds will be similar. Okay? The naming conventions will be different, but the options will be same across different cloud. So we need to be proficient in any one cloud. If you're going for the interview also, they may have requirement for the Azure, but you have AWS knowledge. Just go through the some concepts, then you will understand the Azure concepts also. If you have AWS, if you have Azure, then AWS also will be easy. The concepts will be same, but the names will be different and user interface will be different. So this is the complete DevOps burger which we need to focus to become a successful DevOps engineer. Okay. So in our course we'll cover some Linux administration, some Windows administration, and IAS servers, some SQL, MS SQL database, MySQL database, and Docker, Kubernetes, Terraform, GitHub Action, Azure DevOps, and Prometheus, Grafana, and Azure Cloud. These will be covered in this course. Okay, so to start with our session, to continue with our course, we need to have some basic Azure Cloud knowledge. Okay, and some basic knowledge on the build steps, which will be depends on the programming language. Okay. Let's say you want to have Java based application. So for that you require Maven, and Maven tool will build the application and it will produce one var file. For the .NET, MS build or a Visual Studio build tool will be required, so that it will produce the DLL artifact, so that we can go with the continuous integration and continuous delivery process. So these kind of basic steps, steps related to programming language is required. And in the Azure cloud, some what are virtual machines, what are web apps, and PaaS services like MySQL, MS SQL. These are required in the Azure cloud. So anyone is having